So here, fibers like plastics are made from polymers. We looked at polymers yesterday as a combination of small substances or molecules to make one big one. And that one big one is what's called a polymer. If there are many big ones, we call them polymers. So these are used to make threads. These are used to make threads that can be made into a cloth. So a combination of very many thread-like structures, thread. So fibers are just something to deal with threads. So if you combine those threads in several ways, they can be made, they can turn into a cloth. This can be classified into two. One, we have one natural fiber and synthetic. We looked at synthetic. What does the word synthetic mean?
Man-made.
Okay, synthetic in simple is man-made. That's good. Then natural,
God-made.
God-made. That is good. So these ones exist naturally. They exist. We found them there, and when we also go, we shall leave them there. If you don't destroy them. So natural fibers can be classified further into three groups. The first group is from animals. The second one is from plants. And the third one is from the minerals. So you say animal, we have plants, and these are plants and the minerals. These are natural, isn't it?
Yeah.
Then synthetic. Synthetic, we have an example is nylon, polyester. Then this one, nylon. We know how nylon looks like, or anything made of nylon. Yes.
Yeah.
Polyester. What about the polyester material? You know what it looks like. What about silk?
Yes.
You know how silk looks like. Which material is made of silk?
Gomez.
Gomez. People know these materials. I've seen. So those are some of the whatever's under that. So synthetic fiber, these are man-made. These are the examples. From plants, we have all these. Cotton is one of them. They have those type of fibers in them. Even sisal has some. They have those kind of small thread-like structures. If you combine all of them, they will give us our material known as fiber. So from animals, we have all this. Then from minerals, especially asbestos. You know how asbestos look like?
Yeah.
Huh?
No.
Somewhere here we shall look at one. These are examples of them. Have you seen them? They have that element of those fibers inside them, those fibers. So that is the way it looks like. So there are as many as these. These are the asbestos fibers. So what they use them is, you see how these sheets. When did you last see this kind of sheets? These ones here. Where did you last see them?
In the village.
In the village. They are there in the house also.
Here. Yes, they are here at our home.
So they are saying there are some health concerns about those type of sheets. Okay. So there are some health concerns about those type of sheets. So if they are still there, make sure they are fine. So those are the types of whatever they make from those asbestos. Now here, an important use of a fiber is to make a cloth. Then it is then made into clothing. Some of clothes are warm, others are cool, some
Why are
others.
they considered not healthy?
The what? The asbestos. Huh? Who is it? This is Sean.
No,
Uh,
it was Joshua.
Joshua. Joshua. Again is quiet. So there are some health concerns about those type of iron sheets you use. That's why these days they no longer exist. They used to cause diseases to people. They have some
They are still there.
and they are still there, but at least to a lower extent. If you find them, there must be in the old houses.
But teacher, they are here at our home. They're here at our home. So
Yeah.
I almost see them every day.
You almost did
On the
what?
poultry house. I see them almost every day.
Yeah,
On the poultry house.
it is true.
Yeah,
Those days people used to use them for roofing, but because of health concerns, people found out that they cause diseases to human beings.
which kind of disease do they cause?
Yeah, that's true. But yes, which kind of diseases do they cause?
Now you see, you want to know which kind of disease so that you run away from them.
Yeah.
No, teacher.
Uh-huh.
Teacher, it's not that they're on top of a house. Teacher, they're not on top of a house, but they're on top of the poultry house. That's where they are. So that is why we want to know the diseases they cause, because we never know. Even our hens also might fall sick. Even our hens might fall sick. Be downloading. Yes. Chiuzo change bali kitako naho. Chiuzo change mbuza no bali kitawano. Echibuzo cyo kubuza wano buti.
Now,
Nakanya chuandika wano computer.
now you see this.
Yes.
Yes.
These are the list
Now
of
we are
them.
there.
You are now there.
Yes.
Now you are enjoying.
Very well.
Have you seen this?
So
which one of those do you think is most likely to occur?
Lung cancer.
Lung cancer. So that is the main disease actually they cause. They found to have caused that lung cancer to most people, and that's why people are running away from them. They are now using aluminium.
I now get
aluminium iron sheets.
Aluminium roofings. I now get.
Okay. So let's go back to our lesson now. So that is what you have here. So some of them, most of them are used for making those clothes. The clothes, some clothes are easy to stretch. Some of them are elastic, others do not. Some clothes dry quickly.
Like sweaters.
Those ones. Others dry quickly, others don't. They take a long time.
Others take long.
Some clothes,
they take, yes.
Others last long, others wear out quickly. So all this is caused by the material.
Some clothes dry quickly after you wash them.
So all this is as a result of the fiber used, or the material used to make those. If you use a weak fiber, it will also give you a weak
clothes
material. Yes. So
it will wear out.
Some feel comfortable to wear, others don't. Many of these different materials are caused by a difference in polymer molecules. that is in the fiber.
Mm.
So those molecules in the fiber bring all these differences. Okay.
Mm.
Now, when you look at
Yes.
this question down here, there's a question I want to show you that you are going to struggle with here. End of this chapter questions. Have you seen them?
Mm.
Anena,
Yes.
Anena, I don't know now. Where's Anena? Anena, you're not getting me properly. Anena is not getting me properly.
Yes, teacher.
Are you in a noisy place? Hmm?
Yes.
First, make sure you get out of the noisy place.
Her background is not good. Let her.
So, Anena, make sure you get some better place. Otherwise, that place you are in is too noisy. So here there is a question that starts like this. Plastics, metals, and ceramics are very important and useful materials. Select one of them and describe what life might be if the material you have selected was no longer there. Okay? So that is one type of a question you see there, that if plastics, materials, or ceramics are important things and useful materials, get one of these, any of these, and describe what life would be if the material you have selected was not available. Then 2, describe how you would compare your home to make it cool in summer and warmer in winter. Okay, you make it cool in summer and warmer in winter, and give reasons for your suggestions basing on the materials you have seen above. Which type of material would you use in summer? Which type of material would you use in winter? And give the suggestions for your answer. Then there is this one that says each of the following objects is made up of fiber. In each, describe the most useful property that you would want the fiber to have. Now here is the seat, a set of seats covered, set of seat covers for a car, a sweater for winter, then a baby's nappy. You have studied fibers. Let's start with this one. The seat of a car. Who is giving me that answer? And why you have chosen that material under fiber? Rosemary.
Yes, teacher.
Give the fiber to which what? Each of the following objects is made up of fiber. Is a seat of a seat cover for a car made up of fiber?
Yes.
Now, give me, in each case, describe the most useful property that you would want the fiber to have. One is the seat of a car, that cover of the seat of the car. Which type of material would you wish? Would you wish that whatever to have?
Smooth.
Smooth.
Animal fiber.
Animal fiber. Why?
It's soft. Smooth. Strong.
Now, don't you think if it was, what about slippery? Isn't it slippery?
No,
Animal fiber.
it's not slippery.
Now, let's look at this.
Fiber.
Eh? Okay, that is a part of you. We shall look at these things.
Fiber.
Let me not spoil your day. So these are the whatever we are going to do. You do, and then when we meet on Friday next week, we shall start from there. Okay?
Yes.
This is a part of your assignment. So you look for ways of either
Yes.
taking a screenshot or which other means?
Downloading the book.
Downloading the book. That is in fact a better option. Download the book. It is on page 50. End of chapter questions. Okay?
Yes.
Okay. So our main point of discussion, this one is an activity we are supposed to look at, but the main property here, I think we are done with these problems of polymers and the fibers and what. Our main point of discussion here today was this other topic. Maybe if you have a question before I shift. Chapter 5. Any question before we go? Okay, someone is concerned. Say, teacher, put it in the homework, please. I'm going to put it there also. We don't have. Yes?
Yes.
Okay. Now, let's shift away from materials. Shift away from materials. We have now known the materials to use. Come to chapter 5. We want to know what happens if any of those materials is burnt, or if any of them, the main important idea here is to know if something is burnt, what happens? Does it temporarily change or it permanently changes? Have you ever heard of those two changes? Yes?
Yes.
You have ever heard of them? When they say
Yeah.
something is as temporary change, what does it mean?
Temporary. It means it has
It
stayed
means
there for a short.
changes to any other state of it changes back maybe.
It does what?
It changes to
It
another
changes to
state.
any other state for a certain period of time, then it changes to its normal state
It's normal state
a
after
period
some
of
time.
time.
Okay, that is temporary.
Yes.
People those days used to build the graphite houses. When the grass maybe gets spoiled from up there, they remove that grass and put another one. So that one was not called it was not a permanent house. But these days people have changed from those graphite houses to iron sheets. That one is called a permanent what? So if you want to remove that permanent house, you remove everything and destroy, isn't it?
Yeah.
So
Yeah.
so temporary and permanent changes to materials. So at the end of this chapter, we must be in position to describe what is called, the keyword is one, physical change. You get it?
Yes.
Then chemical change. Then you must be in position to tell us that there is also something called reversible and irreversible. Isn't it?
Yes.
Then they must be permanent or temporary. All these keywords, you must be in position to differentiate them. Okay? So when you get ice, you know ice?
Yes.
Yes.
Ice in a state is a solid, isn't it?
Eh,
When you want it to turn to a liquid, what do?
you
Melt.
heat
You heat.
it. Melt.
What is the scientific word to mean heat? You do what? You melt, isn't it?
Yes.
It turns to a liquid. If you want this liquid to turn to a gas, what do?
Boil.
Boil it.
You boil.
Boil it.
Evaporate.
So the common
You
word
boil.
they use is evaporate. Okay? So evaporation is a process by which a liquid turns to
Gas.
a gas. Huh?
Yes.
Yes.
Now, if something turns straight,
Down to vapor.
it turns straight from the solid state to a gaseous state. How do you call that one?
Sublimation.
Condensation. Condensation.
Hmm? Okay.
Evaporation.
Ice straight to a gas. How do you call it?
Evaporation.
That means a solid has turned straight to a gas.
Evaporation.
Then also you can change this to this one. This is evaporation. Ice to a gas.
No.
Sublimation.
This is sublimation, isn't it?
Yes.
Sublimation. Also a gas.
Yes.
A gas can turn straight to a solid. How do you call that?
Sublimation.
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 Now, where is condensation? Condensation is what?
Gas to solid.
Huh? Gas to
Liquid.
gas to liquid is called sublimation. What about a liquid to a solid?
Freezing.
Freezing. Okay, that's good. Now, some of these, if you know how these things behave, it's going to give you the difference between temporary and permanent, and it's going to help you know how these changes come about. Some of the changes they ask for here in the chemistry, we are interested in knowing if you know that something can reverse, or if something is not reversible, irreversible. This is irreversible. Now, all these two things give us the two definitions of the words we are going to look at: physical and chemical changes. Now, temporary, this is a piece of fat. You know fat?
Yes.
When you heat this fat, what happens?
It
Melts.
It melts. It turns to a liquid, isn't it?
Yes.
Yes.
Now, when it cools, what happens?
It changes back to its
Changes
normal
back.
state.
Solidifies.
Is there anything that has changed?
Turn back to a solid.
Is there anything that has changed out of this heating of that fat?
Yeah, it changes. Then
Is there anything that has changed out of it?
No, because it's a physical change.
Yes, true. So now here, it has only changed physically. When you see it change from solid to liquid, that's what happens. But the original state of the thing has never changed. When you cool, it comes back to its original state. So this type of change is called physical
Change.
Now, according to who? According to Sean. According to Sean, what is a physical change?
A physical change is a type of change where no new substance is formed.
Where no new substance forms. No new substance is formed. We have Julie also. Julie. Julie. Hey. Julie is quiet. Julie, unmute. Unmute. Okay.
Yes, teacher.
What is a chemical change? Chemical change.
A chemical change. Is
Huh? Yeah? Hey.
Teacher, I don't know.
Someone can help.
A chemical change is a change where new
Since it's formed.
One person. Allow Rosemary to say.
A chemical change is a change where a new substance is formed.
A new substance is formed. Thank you very much. So here, if you melt the ice, or if you melt this fat, it is just going to change state from solid to liquid. If it cools, turns back to a solid.
fat.
That is a physical change. It has just changed physically. But if you want something to change chemically, an example is I get firewood. What is the state of firewood there? It is a solid. If I burn this firewood, what are the end products of burning wood?
Ash.
Ash. Now, is ash wood again?
No.
So it has undergone what we call a permanent change until never come back. You get it?
Charcoal.
Even charcoal. Now, do you know that the chemical name or the chemical whatever of charcoal is carbon? Did you know that?
Yes.
You know that if you are talking about charcoal, in simple terms, chemistry, you are talking about carbon.
Yes. Yes.
So, if you say charcoal, this is charcoal. If you burn charcoal is one of the whatevers of carbon. And if you go to that part of carbon, you will find that charcoal is carbon. There are several ways to which this carbon exists. Even diamond, you know diamond?
Yes.
Diamond is part of this substance. Graphite, an example of graphite is that pencil lead that you have. It is part of this. Then other types of carbon that involve that are called amorphous carbon. Those ones that don't have shape. We find the charcoal there. We find many other things there. Okay. Or if somebody wants to tell us that carbon has shape, this charcoal have shape.
Some
have shape.
These round ones.
Which round ones?
There's